We're going to be talking about commandeering Kubernetes with Elixir. That's a nautical term. What we're going to do is we're going to look at implementing something called the operator pattern in Kubernetes. So my name's Cory O'Daniel, and my clicker's not working. Oh, I knew this was going to happen. Jeez, $9 Amazon clicker. Okay, here we go. Actually, my slides just aren't changing. That's just super fun, huh? Hold on 1 second. Let's try this again. There we go. Okay, so yeah, as Brian said, my apostrophe is not required. It destroys almost every piece of software I enter my name into. I'm a senior YAML architect at Container Heroes. We specialize in large-scale multi-region Kubernetes clusters, operator development, and CI/CD systems like Spinnaker. I created a framework called Bonny, which is a general-purpose Kubernetes framework for extending Kubernetes. I said Kubernetes a lot there, and you can find me online at Cory O'Daniel on GitHub and Twitter and LinkedIn, I guess, like if that's what people do. So, elephant in the room, all right? Say it with me, Kubernetes. Kubernetes. Okay, so if you're not familiar with the term Kubernetes, it's Greek for helmsman, but like don't take my word on that because I'm not Greek. And I'm going to attempt to not go overboard with nautical references. But so like, why is there a Kubernetes hype guy at an Elixir conference, right? In my day job, I spend a lot of time encapsulating like common like day 2 operational tasks in Kubernetes operators. We build a lot of abstractions for developers to build, monitor, and observe their apps in Kubernetes. And we do most of this work in Elixir. Elixir feels like a really good fit for something called the operation pattern or operator pattern in Kubernetes. And we'll get right into that. So what is the operator pattern? The operator pattern allows you to codify the expertise of a human operator with deep knowledge of managing an application or set of services and how to react to problems when they arise. So the operator pattern lets you add extensibility to Kubernetes without having to fork Kubernetes and then get it patched back into main. It also allows you to do things like package best-in-class deployments of complex software and systems like databases. So an example of an operator that you might see, this Chrome bar at the top is super cool, by the way. You guys love that? I'm the first one to do this, so you're welcome. So one of the things you can do is create highly available databases declaratively, right? So let's say you need to use Postgres for your Phoenix app. How do you get a Postgres? Where do I get that from? Do I go into the AWS console and create an RDS database? Do I use Terraform or Ansible? If I'm deploying with Kubernetes, wouldn't it be awesome if the same tool that I use for deploying my application, I could also provision a database? And so there's an operator called kubedb that allows you to do this. It actually lets you deploy 6 different databases in a highly available fashion with just a few lines of YAML. So here we're saying that we want to do deploy Postgres version 11.5. We want 3 replicas of it. We want hot standby. How does Postgres work? I don't know. Just give me one. You can do this with MySQL, Elasticsearch, Kafka, Redis, etcd, and memcached, I believe, through kubedb with just a few lines of YAML. On-demand database snapshots. Who remembers the flags for doing a PG backup offhand? No one, right? So why isn't that like just something that like the computer can do for me? Like Kubernetes, just back up my thing and put it in GCS. And so kubedb offers the ability to do snapshots of databases agnostic to the type of database. I can simply say, hey, my Postgres database, back it up, put it on GCS, thank you very much, and it'll do that for me. Tls certificates. How many people have set a reminder for 4 years from now to renew a TLS certificate so they don't embarrass themselves on Black Friday? Or maybe you use Let's Encrypt, right? But Let's Encrypt still has a lot of hurdles to go through to get Let's Encrypt set up. Wouldn't it be great if you could just say www.example.com? I always need a TLS cert. It needs to be up to date. It needs to be terminated at my ingress, and I don't want to think about how it works. And I can provision that right alongside deploying my application with the same tool. S3 buckets, right? So eventually we're going to need to store some assets in an S3 bucket. How do we get that S3 bucket? Do we go back to Terraform or Ansible? Do we go into the AWS console? our database migrations live right alongside our code, but when we get to creating things like S3 buckets and resources in the cloud, we go and use these other provisioning tools to do that. If I'm deploying my application with Kubernetes and using kube control, it would be fantastic if I could just provision that bucket in the same loop of deploying my application. And the service operator by AWS allows you to do this. It actually, I think it supports about 7 or 8 different resources, so you can make DynamoDB tables from Kubernetes. Fantastic. I don't need Terraform for that. You can create, I think you can do elastic cache instances. Don't need Terraform for that. I can do it all from Kubernetes. So what is the operator pattern? Why is Elixir a good language for developing operators? So the operator pattern doesn't do much. It doesn't need to do much. But what we'll see here in the purple terms are words that resonate with us as Elixir developers. So we're going to process a stream of chunked HTTP responses, or HTTP bodies that are add, modify, and delete events. We're going to continually reconcile state changes of Kubernetes resources. And then we need to manage background tasks, processes, and state. Like, this describes why Elixir is a good solution for something, right? Like, this just feels right. And there are tools for building operators in Go. There's actually 3, and they're fantastic. There's Kube Builder, the Operator SDK by CoreOS, and something called Kudo. They're all fantastic. Personally, like, I write Go, but it just doesn't feel as natural for me as writing Elixir. So it's one of those things, they say lazy developers, right? So I thought I could either write my first operator in Go and spend 2 days struggling with it, or I could spend 2 months writing a framework, and then I could do it in like 2 hours in Elixir. So I don't know like how much effort you have to put in to be lazy, but like I did it, like I made it there. Cool, so the operator pattern, great, but like why Kubernetes? Like who cares? Like do we need Kubernetes? We have the beam, like why do we need Kubernetes? Who uses Kubernetes now in production? Wow, nice, okay. You guys are gonna know that I made most of this up. Just kidding. Yeah, so you know, Kubernetes is great. Not everything can be on the beam, right? So we have other applications that we need beam-like resiliency for. And so what I want to do is just for people who aren't familiar with Kubernetes, just want to go through a couple of the features really quick. I'm going to totally pitch you guys on this. You're going to love it by the end of this talk. So one of the big features is service discovery. So this comes in the Kubernetes cluster out of the box. So I have an application running on this node. It says I need to talk to microservice A. Kubernetes goes, great. It's right over there. That is a part of Kubernetes just by using a service in Kubernetes. The other nice thing with that is Kubernetes won't serve traffic or do service discovery, serve nodes that are experiencing issues. So if you have an application that is starting to falter, Kubernetes won't include that in the response. Scaling. There's a couple of different ways to scale in Kubernetes. The one that you'll usually interact with from an application developer's perspective is horizontal scaling. So what that is as your application's receiving requests, maybe its CPU is starting to get high, Kubernetes can add an additional replica of your application to the cluster to serve those requests. At some point in time, those nodes start to get full CPU and memory-wise, and Kubernetes will do something called cluster auto-scaling and add an additional node to the cluster so that you have more compute and RAM. There's also a newer auto-scaling feature called vertical scaling that can add CPU and RAM to a running instance. Storage orchestration. So occasionally you need to store stuff. Kubernetes provides a nice way to have multiple types of storage, all through declared and mounted through YAML. So whether it's an NFS drive, an SSD, some block storage, or a host path, there's a pretty simple storage orchestration built in as well. Automated rollouts and rollbacks. So as we're deploying our applications, one of the features that Kubernetes provides is automated rollouts. So we can phase how our application is getting deployed onto the cluster. We can say, you know, I'm going to withstand a 33% outage on this application to replace it with a new version, or I can surge and I can start up more replicas of my application as I'm rolling it out. And you can do that based on count, or you can do it on percent. So here I'm rolling out 33% of my cluster, and then 66% of that application rolls out afterwards. Automated bin packing. So I think this is one that's like, that's what Kubernetes does. But it's one of those features that like, if you don't think about like what it's really doing for you, like it's awesome, right? So we're in the cloud. We're renting somebody's computer, right? So we have an application running on a VM. It's got 30% CPU utilization. We feel great. Like, pager's not going off at night. I'm sleeping through the night. But we're renting that CPU by the minute, and we're paying 100% of the price for it, but we're using 30% of it. So like, didn't we just waste 70% of our money? Yeah, you did. So what automated bin packing does is Kubernetes will place workloads on a node to try to maximize the utilization of the CPU and RAM on that node. The slowest transition here, it's packing it. There's going to be 2 more workloads, and that node's full. Self-healing. So occasionally things die, like that happens. Maybe you have an out-of-memory error. Kubernetes has to shut down an application, bursts into flames. It'll bring that application back up after it's failed. There are a couple of different ways to do health checks in applications as well as resource limitations, and Kubernetes can do self-healing in the event that your application's failing or if you have runaway memory usage. There's a lot of other stuff that Kubernetes can do. So secret and configuration management. There might be opinions on secret management in Kubernetes in this room based on the number of hands I saw in production, but it does do secret and configuration management for you. A single deployment tool for all of your things. It's called kubectl. It's a CLI tool for managing resources in Kubernetes. Some people call it kubectl. I do because I love it. And so I'm going to call it that for the rest of this talk, and if people get mad about it, that's fine, because I'll kubectl them. And I know that the guy that made it said that's not how you pronounce it, but I don't care. And then portability, I think, is probably one of those features. It's like, it's a non-feature, but it's great. Like, Kubernetes is quickly becoming the kernel of the cloud, right? It's becoming approximately like a POSIX standard. With the Cloud Native Compute Foundation starting its conformance program, there's 60+ cloud providers that run a conformant version of Kubernetes. So what does that mean? You can take your app and you can move it to another cluster. You can take your app and you can move it to another cloud. And you can take your knowledge and you can move it to another company. It is learned complexity instead of homegrown complexity. And I think that's one of the really important features that you get from learning how to operate Kubernetes. Sales pitch is over. Who needs some Kubernetes consulting? No? Nobody? Okay. So we learned from that Kubernetes can help us scale applications and heal applications, right? So if you guys are ready, like, let's weigh anchor. So I was trying to figure out, like, how do you do a crash course on Kubernetes to get people that aren't using it in production up to speed with people that are using it in production. And Kubernetes from the ground up is gritty. There's a lot of things going on inside of Kubernetes, and it can be difficult and it can be difficult to describe. We'll take a little tiny peek at how master nodes work in a bit. From the top down, Kubernetes is also extremely intimidating. This is a standard Kubernetes cluster, and this is 61 resources that Kubernetes is operating for us, right? So it's essentially 61 things that the operational team doesn't have to do anymore because Kubernetes is going to do it for you, right? So like, to talk about all this from the top down, like, we'd be here for months. So what we're going to do is talk about it from the perspective of something called the deployment in Kubernetes. But before we do that, we have to talk a little bit about some common things you see in all Kubernetes resources, and that's attributes and metadata. We'll just briefly go through this. This talk is a lot of YAML, by the way. It's like 9 nines of YAML and like 0.000000001 of Elixir. So what you see here is we have something up at the top, API version and kind. All resources in Kubernetes have this. Kubernetes, behind the scenes, is a giant REST API. And this version is different versions of your REST resource. So what we're saying here is this is a resource called a pod. It's V1 of it. Put it in that REST API for me. We have a metadata key as well. There's a couple of things under here. The 3 important ones are name, namespace, and labels. Labels allow you to group different resources together and find those resources using kubectl. And namespace and name are actually used in the URLs that are generated for the REST URL. Spec at the bottom is a data payload of the data that we're trying to store in Kubernetes. So how that maps to the REST path, like, this is probably something, if you've used an MVC framework, you're probably very familiar with these types of URLs here. So we have APv1, so this is V1 of the pods API. I am interacting with pods underneath a namespace called admin CMS. And then the second listing here is an actual get or show of a specific pod called Nginx. So those namespaces and names have to be unique within a namespace in Kubernetes per the type. So I couldn't have 2 Nginx servers in here. You can have 2 Nginx servers, they just both can't be called Nginx. Okay, so that's how metadata maps to a URL. So let's talk about the two components that make up a deployment. So the first one that you'll rarely interact with directly or create directly in Kubernetes is something called a pod. So a pod runs your applications. This is where your containers are. If you've used Docker Compose before, for people that haven't used Kubernetes, it's fairly similar to a Docker Compose file. You can definitely have one container in it, and that's common. You could also have multiple containers. Maybe you have your API, a SPA pre-renderer, and memcached all inside one container. A pod lives and dies as a cohesive unit, and it acts as a logical host. So they share disk space, They share volumes, and they share network. So Kubernetes is a series of abstractions. And one of the abstractions that we have and that we use often in Kubernetes is the deployment. And so a deployment is an abstraction on top of a pod. It tells pods how they should be replicated, how they should be rolled out, and how they should be rolled back. If you notice on the previous slide, from spec down, if I were to copy and paste that, it's the exact same code at the bottom of this deployment. This deployment actually prints out pods using this template here. Cool, so we know that deployments are a way of managing the life cycles of pods in Kubernetes. Pods do the work. It's pretty much a big REST API with a small storage mechanism inside. Briefly go through the ping pong of like what actually happens inside Kubernetes when you do a deployment. And this is all going to come back to operators, I promise. So you're going to see two sets of lines here. You're going to see green posts and red gets. There's this API server that sits in Kubernetes. It's the REST API. You use it as an operator. Your CI/CD system uses that as an operator. And then internal to Kubernetes itself, there's something called the controller manager. The controller manager uses this API as well. So as we post a bunch of YAML to Kubernetes, we get a deployment. So that deployment is now stored in etcd, which is the database that Kubernetes uses. That deployment isn't doing anything yet. It's just sitting there. There's no code running. There's no containers. The deployment controller is constantly polling the API. It's very similar to the controllers that we'll see in a minute when we start talking about operators. It polls, it sees the deployment, picks that deployment apart, and it creates something called a replica set. A replica set is the version of your application that's currently being rolled out. That still doesn't do anything. It's just there. It gets written into etcd, sits there. The replica set controller polls, sees the replica set, creates some pods, still nothing is happening. And there's one more service that is running, that's the scheduler. The scheduler is also watching the same REST API, just like our operators will, for pods to be created, and then it will schedule those on the nodes. So that goes out to some nodes, and then here, like some really cool node stuff happens. Like, goes to kubelet, ends up in a Docker, got some applications there, it's magical. There we go. So, writing a Kubernetes operator. So, like I mentioned earlier, there are a few libraries that you can use that are written in Go. There's additionally Bonny. But to write an operator, you can actually get started with just YAML. Like, how beautiful is that? So our first operator is going to be a to-dos app. And this is the most over-engineered to-dos app that's ever been created on the planet. This was originally running on 40 nodes. It's beautiful. It's beautiful. So when we make an operator, there's two things that we make. There's something called a CRD, which is a custom resource definition. Custom resource definition is a description of how a resource should act in Kubernetes. It does two things for us. It creates the REST endpoint, and it creates the storage mechanism in etcd, along with the fields and validations we expect in that data blob. So when we saw pods and deployments earlier, there is a spec for pods and deployments in Kubernetes as well. They aren't CRDs. CRDs are our ability to add things similar to pods and deployments. So we're going to use a CRD to make something called a to-do. But we'll also need to do something called a controller. So a controller is where your actual logic lives. So this is your controller is a deployment in Kubernetes. And it acts on that API just like the controller manager, deployment manager, and the replica set controller act on that API. It just continually polls, looking for things that are happening in the system, and then reacts to those, reconciling any changes that it finds in state. So, the to-do CRD. Now, you guys are all sitting, right? So anybody who hasn't seen Kubernetes before, this thing's a lot of YAML. That's YAML, it's page one. Actually, there's something to show you on page one, then it's just a whole lot of pages. When we're defining this thing, we can give it the versions here, so we can list how many versions are here and which one we're currently serving. The naming is here as well, so kind to do. That is used by us when we're making YAML or creating YAML payloads. That's us declaring the kind of resource that we're going to make. Plural, whoops, I'm dumb. Plural is the actual word used in the URL. And then this validation section here is OpenAPI, Swagger validation. So this is us defining what a to-do should actually look like, very similar to like a database schema or an active migration kind of. There's a lot of fields here. I'm creating a, so there's a lot of metadata here. You actually define the metadata itself as well in Kubernetes, so I have to put on API version and kind and all that stuff. When we get down to the very, 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 very bottom, you can see like things that we might actually be interested in for it to do, like the name of the to-do, the details, the markdown for the body of it, and then the state of the to-do, pending, in progress, blocked, completed. There's a whole bunch of stuff you can do when designing CRDs. This is definitely not, like this is just to show like the pain of it and how simple Bonny can make it for you. So what does an actual to-do look like? Like after all that YAML, when I go to make a to-do, like this is a to-do, that's it. We got a to-do in the system now. It's called create slideshow. Its URL will be to-dos/create slideshow, create-slideshow, using the name there as the ID. It has some markdown as the description, and then the state is completed. I just finished this slideshow like 10 minutes ago, so that was a lie, by the way. So interacting with these resources. So at this point in time, with just this YAML, we actually have a functioning Kubernetes operator. It's not the most interesting operator in the world, but it does do some things. So we'll go ahead and use kubectl to apply that big YAML blob that we saw, and we can see Kubernetes says that it was able to create our to-do operator. I've got a YAML file with a couple of the to-do tasks for this talk. I went ahead and applied that, and it created 4 to-dos for me. One of the really interesting things about the kubectl kubectl CLI is it can interact with these new resources. So your CLI actually changes. Like it knows what a to-do is now. So I can say kubectl get to-dos, and it can list my to-dos. At the bottom of that YAML, there was something called additional printer columns that lets you define like what this UI should look like when it renders out. So I'm simply showing the name and the state of these resources. And then you can also use it to actually grab a resource and get the full data payload of it. So I'm doing kubectl get to-dos create slideshow here using the output YAML option. There's a lot of metadata that Kubernetes attaches to all resources as they come into the system. This red section right here is showing you the self-link. This is the actual REST URL or REST path for this resource. And so you can see that the APIs is to-do operator Bonny run/v1, namespace default, to-dos, create slideshow. So all that metadata was used to create this URL. And then there is the payload that we registered by using kubectl apply. So at this point in time, we have is a worldwide, globally distributed to-do app, command line based, and like we don't have any code. Like how cool is that? Like Jira, like this is going to put Jira out of business in no time, right? Like this is actually more user friendly than Jira, right? Okay, so this is where Bonny comes in. So I mentioned earlier, Bonny's a framework that I've been working on in Elixir to write Kubernetes operators. So it does a lot of stuff for you. So my main goal was to obviously handle the event lifecycle of events, but I also wanted to like de-boilerplate creating operators. So Bonny does all of RBAC generation for you in YAML. So RBAC is role-based access control. So this is essentially the permission model inside of Kubernetes. Bonny handles that for you. It creates a secure deployment of the operator itself. So we have to deploy this thing into the cluster, we have to request resources from it, and we probably want it to be secure. So it has a pretty secure default that it applies when it makes this deployment for you. And then it also creates that 180-something line CRD file. It builds that for you as well. And then, so what you see as an Elixir developer is you get a controller with 4 functions, add, modify, delete, and reconcile. So it's very similar to what you might feel when you're working with a Phoenix controller, except for the reconcile part. So the goal of Bonny is to be a complete extension framework for Kubernetes. There's probably 5 or 6 different ways to extend Kubernetes. Currently, it supports operators and writing custom schedulers. I decided to go with like the thing people cared about and the most absurd feature at the same time. And it's named after Anne Bonny the pirate because everything's nautical, so why not? And I needed an X, and I was like, cross swords is close to an X, so yeah, I don't know. So generating a controller. So we add Bonny to our mix file, mix.exs file. You can add Bonny to any application. You can turn any application into an operator. You can use an unsupervised application or a supervised application. If you need to do like out-of-band processing of events, like let's say a resource has some sort of like timeout or lifetime on it, Bonny has a periodic task scheduler. So if you create an app that's supervised or put it in a supervised app, you can use the periodic task scheduler to schedule things to run out of band with the event loop in Kubernetes. So here we do mix Bonny gen controller to do to-dos. That's the only inputs you need. It creates an XUnit set of tests for you and a very, very basic controller. So this controller here, you can see up at the top, there's the scope namespace. This is one of the attributes you have to specify. So Bonny uses these attributes and some information it gets from the module name to generate most of the YAML for you. You can also use rule as one of the annotations here to specify RBAC rules. So you can simply just say, like, I want to be able to create pods or delete deployments. And Bonny will create all of the YAML for that cluster role or role binding, the actual role binding and the service account. It adds some dialyzer specs here. You'll see that the method signature in all 4 of these functions is exactly the same. It receives a map. That map is the map version of the YAML payload that was submitted to the Kubernetes API, and it's expecting an OK or an error atom to be returned. So Bonny uses under the hood telemetry and Notion to do metrics tracking. It doesn't currently expose a metrics port for Prometheus to gather information from, but it does collect these metrics, something I'm hoping to add fairly soon. So returning OK and error here is how it keeps track of which one of these events is failing and succeeding. So I usually do a little refactoring right after I generate this. I like to make my Kubernetes resources idempotent. Everything that goes into my Kubernetes cluster, I like to have the same function acting on that, so it's hopefully always in a good state. So I actually alias add, modify, to reconcile. So when I'm implementing operator controllers, I pretty much have to handle when something's deleted, and otherwise, like, get the system to a stable state. So when we're deleting things here, like, this is one of the things I struggled with in this talk, is like, how complicated should I make this def block here? Like, right, we all know Elixir, like, we can write as complicated code as we want. So I just went with like loggers, like, why not? Like, it's easiest to demo. So here I'm just simply doing a logger. You can do anything you want here. You could act on the Kubernetes API, you could act on the AWS API, GCP API, your own API. You can use the periodic task scheduler to schedule things to happen out of band with this. Like maybe when a task is created, if it's been sitting in pending state for 6 days, we want to send an email to the project manager saying, hey, somebody kick that developer, or leave them alone. So here we're just doing some loggers. So when we delete something, what we're going to see in the container logs is deleted to do the name of the to-do. Can we go home early? And reconcile, we have 2 method signatures here. One, we're specifically capturing a completed state. And in this case, maybe we want to use Bamboo to send an email saying that a task has been completed. We're simply going to log woohoo. And otherwise, when events are coming into the system, we're going to keep track and log the current state of those to-dos. So behind the scenes here, you'll notice at the top, use Bonny controller. How this works behind the scenes, there's two gen servers, the Reconciler and the Watcher. They both have different behaviors. So the Watcher is actually doing the add, modify, and delete. So that's processing this event stream. So that is a real-time event stream of events happening in Kubernetes. You have a little bit of time travel that you can do in there. And then there's something called the Reconciler. And so the important part of the Reconciler is, like, no matter how good Kubernetes is and how good your operators, or how well your operator is written, like, occasionally your operator will be down, right? And so if your operator is down while these real-time events are happening, did a to-do happen? Like, I don't know. So what the reconciler does is, while the watcher is actually watching the real-time events, the reconciler is getting the current list of everything in the system so we can reconcile the system and address any changes that have happened while we're offline. So you can kind of see the add, modify, and delete as an optimization over just the regular reconciliation. Building and deploying an operator, right? So like the Elixir part's the easy part, right? We just put some code in there and yay, we're rich. But now you got to get this thing into a Kubernetes cluster, which is the hard part. So building and deploying an operator. So Bonny has a couple other tasks to help you along. Has gen Docker file, which creates a pretty standard Docker file for this application. It's a two-phase Docker file. It builds a release, runs as nobody, based on Alpine. I think it comes out for pretty basic app to like maybe 18 megabytes or so. It also does YAML manifest generation for you. So remember earlier we saw that 180 lines of CRD. Well, there's also about 183 lines of deployment, permissions, service account, all this other stuff. And you can use Bonny gen manifest to generate all of that YAML, so you don't have to write it. So there's 180 lines of YAML it just saved you from. So this is building the CRDs, RBAC, service account, and a secured deployment. And if we peek at that manifest, you can see some of the YAML in air quotes here. We don't have YAML on Elixir. You can't write YAML on Elixir, right? So this is just JSON strings concatenated with dashes. But it works, like whatever. So here is creating the custom resource definition. We can see the kind, plural, singular name here. This is the role that it ends up creating for this operator to run as. So it's giving it full access to custom resource definitions. If you're a Kubernetes permissions guru, you'll be like, why does it have full access? There's a good reason, but it's outside the scope of this talk. And then it has full access to to-dos as well. So it can create, update, delete to-dos. And all this is just generated from the annotations on that controller. This is the bottom half of our deployment. So it creates a deployment with some CPU limits. It attempts to run as a guaranteed quality of service in Kubernetes. So our resource requests and limits are exactly the same. That's tunable from your config EXS file. And then it also sets a couple of options on the security context here to disable privilege escalation, disable running as root, running as a fairly unprivileged user, and making sure the file system's read-only. So you can tweak this if it doesn't work for your operator. If you did need to use debts or something like that, you could modify this, but that is the default configuration it generates. So let's apply this thing. Let's deploy some Elixir codes to the Kubernetes. So if I do kubectl apply, we'll see that there's a couple of resources created here. There's the deployment itself. So this is our actual operator's deployment. There is a couple of cluster role things. So those are our permissions and our bindings, the service account, and then the actual CRD. And so now we can use kubectl, and we can get deployments in pods. And what we should see is our to-do operator. So again, in Kubernetes, a deployment manages pods. Pods are actually doing the work. So while we did make a deployment up there, that deployment is managing, just like our operator, the lifecycle of pods being created. So it created this pod for us that is now handling to-dos that are coming into the system. So now we should be able to do that same YAML we did earlier where we're creating and deleting to-dos. But Kubernetes should be, or sorry, Elixir should be interacting with them. So we do kubectl apply. We've got 4 to-dos. I can list them. I can delete them. And then if we look at the container logs, we can see Elixir interacting with all these lifecycle events as they're happening. So that's pretty cool, right? Like, no more Jira. But like, where do we go from here? Yeah, so like the to-do operator, like it's fun. Like to-do apps are what we all do for a demo of new technology, right? It's a pretty trivial example, but what operators help us do is they help us automate DevOps tasks, day 2 operational tasks like database snapshots, TLS certs. We saw how that they can create building blocks for us that we base our applications on, like Postgres and Redis. But what about like a declarative application management, right? Like with 12-factor in the cloud, we were all promised declarative interfaces, but 180 lines of YAML doesn't feel really declarative to me. I get that it is, like one man's declarative is another man's abstraction and all that, but as developers, I don't think we should have to worry about deployments, services, databases, TLS certs. We shouldn't burden everybody on our team with being a Kubernetes expert. If application environments are a function of their inputs, why should a developer be concerned with anything but those inputs? So this is the application operator. So this is something that I'm hoping to release soon. The Container Heroes has been working on, and it is an abstraction on top of deploying applications in Kubernetes. And the goal of this is to fully abstract away the Kubernetes details, dependencies, and data services. So we can see here, this is me deploying an application to prod, namespace prod. I have something here called an application template, which is effectively what the ops team would have used to define this application. I can set a host name, like this is where I want it to be hosted at. TLS, like hook into this host name and make me a TLS certificate. Don't make me think about let's encrypt prod and all that jazz, like here's my name. The environment and log level that I want to log. SQL, right? Like I need SQL. I need a version of Postgres. Just get it for me. I don't care how we get it, I just need Postgres. And here I'm gonna use maybe an RDS driver. It's gonna make Postgres 11 for me, right? So then when we move to staging, well, maybe we don't have money to run RDS for staging, right? And so in staging, maybe we want to use a different provider to get us the same Postgres, right? And so if we're spinning up these staging environments kind of ad hoc, the one problem there is they don't have data in the database, right? So shouldn't I simply be able to say I'm making a staging environment, and it's a staging environment, duh, it should have like realistic production data in it. And I should be able to say populate my staging database from production. So we do copies of production into staging. If you don't like that idea, maybe it's production-like data into staging. But you'll notice here there's no Postgres URL, there's no credentials, there's no environment variables. It's very much a declarative interface for saying, like, this is how I want my application to work. Don't make me think of any of that other stuff. And so if we boil production and staging down to just a couple of variables that differ between the two of them, have you guys used review apps in Heroku before, or feature branch reviews? Like, why isn't all of our software like that? Like, why can't I just simply say, like, hey, like, I need this to be on this domain, pull request 73.example.com, and this is how I want to get my data into the database. So on every single pull request for every single branch, I have a complete copy of my infrastructure deployed on Kubernetes available for me to use. And in this case, maybe I don't want to use a staging backup. Maybe I want to use something called a seeding strategy, which in this case for Phoenix app would just use Ecto to seed the database. So that's the power of extending Kubernetes with Elixir. Thanks. Are there any questions, or are you guys just ready to build this thing?
Do we have any questions? Oh, hold up.
Where's lunch? Am I right?
Hi, yes. So I saw on one of your earlier slides how you have KubeDB described a Postgres instance. And there was one property called revisions, or sorry, not replicas, and it had three. In Postgres replication, it's a pretty complex operation. And imagine if you are defining operators like you are here with Bonny, there can be situations where you have a simplistic property that actually describes a rather complex set of setup.
Yeah.
How much control do you have over the transition from that simplistic property to complex?
Well, so just a note, KubeDB is a separate tool for, that is an operator itself. It's not built with Bonny. It's just one I was using for an example. Yeah, so I mean, as far as like the in-betweens of how much control you have when you're using an operator, like it's still your cluster, so I'd say you have all the control you want, but if you're using that operator, I mean, it's fairly like using any library package, right? So it's like if you want to change its behavior, you have to fork it and deploy your own version of it, right? I would honestly say, like, personally, I like to fork and deploy my own versions of almost everything that's in Kubernetes rather than just trusting somebody's Docker image or application that is just going to do what they say it does. But if you needed to change the behavior of an operator, it's either going to come into forking it, or it's going to come down to adding extensions to it. That being said, like, it's still under the hood. Like that operator creates stateful sets, if you're familiar with stateful sets in Kubernetes. So you can still act on those as regular stateful sets. So you can modify those after the fact. You might depending on the operator, you might struggle if it tries to change things back on you. But you're kind of leaning into that, this thing encapsulates the expertise of operating the system, and I'm just going to trust that, me with my silly values, I can just pass it in there and it's going to do the right thing.
All right, we have one question over here. Oh.
Okay, so I guess it's kind of a two-part. So if you're working in like an infrastructure that has one Elixir application and a lot of non-Elixir applications, then can Bonny just be used to extend the deployment of the one Elixir application, or do you need to use it against the whole cluster?
So Bonny allows you to create your own operators, and if you want to use that to manage a single application, like that should be fine. So if you want to use it for just managing the Elixir app, like it's agnostic about what it's actually managing, right? So it's acting on this API and it's creating deployments. You could use Bonny to create, like let's say that you had so one of the things we deploy is, we call it the cluster bootstrapper. And we don't use Bonny for this, but it is a place where Bonny would possibly make sense to use it. What it does is it deploys all the common things that we need on a cluster. So Prometheus, OpenTrace, StackDriver, Fluent D, like all that stuff that you need on every single cluster, it just lays it down there constantly. So Bonny can technically deploy all of that stuff because it's just YAML in the end, right? I'm just specifying what Docker images it is. So you could make an operator for each of your apps. What we're trying to do with the app operator that we're working on now is make a generalized operator for effectively web applications, things that feel like Rails and Phoenix. So it's very simple to deploy them on Kubernetes and manage the lifecycle of the database. But yeah, you could make it more generalized for all of your apps, or you could focus it around managing just a single app.
And then the follow-up to that is the off-band like custom task scheduler.
Yeah.
Is that primarily for scheduling tasks relating to the management of Kubernetes resources specifically?
Yeah, so like an example, and this one's probably a little of a nuanced example, but we have something that we released called the eviction operator. And so what the eviction operator does is it lets a workload say, kill me after like X amount of seconds. And the purpose of that is occasionally in Kubernetes, you'll get scheduled someplace you don't want to be. Let's say that you needed some CPU architecture for some reason, and you got scheduled on the wrong type of machine because that machine was fully booked out on resources. What the eviction operator lets you do is instead of thrash that or not schedule that machine, it says, okay, you know what, we'll schedule it over here, but it's not where it wants to be. So we're going to let it run for 600 seconds just so we get some like use out of that node, and then we're going to shut it down and try to move it back over to where it needs to be. So that periodic task is something like, so the pod comes in, and we say, cool, 600 seconds from now, we're going to shut this thing down. And so it's just pretty much scheduling work to do on the Kubernetes API that's out of band with those requests. So in the to-do example, you could use it for sending like nag reminders, like, oh, this thing's been open for 3 days and nobody's worked on this ticket. Like send an email if it's hasn't changed state in 3 days.
Thank you. I could just talk really loud and hope that
I like hearing you in like surround sound.
right, well, so they're trying to record for the video. So anyway, my question was that, like you basically have this container that's serving as the API backend for the operator. Is that container like a Kubernetes construct that Bonny is like abstracting into, or is it literally running like an Elixir server in that operator container?
The operator container is an actual Elixir server, yeah. So it is running an Elixir release. It's not a web server, so that I mentioned earlier that I haven't connected it with Prometheus yet. I haven't bought into adding a web server to it for serving requests. It's just constantly polling. So the controller, Bonny controller that operator uses has that macro creates 2 gen servers under the hood for working with the lifecycle. So there's the watcher, which is just processing this real-time event stream, and then there's the reconciler, who's trying to make the system consistent. And so those just continually run, and those are both running from Elixir.
Thanks again, Cory.